Are you guys winning? Or you still need more time?
Yes, we're winning.
All right, thank you. Please select the answer under the question. Just choose the correct answer. Do not write your solution the choice that you chose.
Sorry, ma'am.
Yes,
I can't see what you're talking about.
it's because you were late. I posted the question. multiple choice question under the pool. That's what you are working on. You are supposed to work on.
It's in the chat.
Yes.
Okay.
Ma'am, do I write the answer under the pool, or where do I select the correct
Nudges.
answer?
You have to choose not on the picture, on the options given below the question, below the picture. Okay.
Under the chat.
Okay, just a second. Let me just share my screen. Okay. Can you guys see my screen? Yep. Can you all see my screen?
Yes, we
Okay.
can.
You see on the question, you have to select it. Either you choose A, B, C. Okay, let me just say I choose C. I select C, then you submit. You see there are options.
Hi, ma'am.
Yes, hi.
I'm lost. What's happening?
Or
Can
should
you please?
I thought I had everything right, but I can't seem to find the end.
That means it's none of the above, your answer.
I, ma'am, sorry. Where can I find answers? I'm failing to.
It means that my problem is that I can't simplify. I'm almost there. Like I can get the
thing is,
right, but I can't
okay,
get.
you just have to try, ne?
Yes, and maybe
Because if you don't want to try, like to simplify right now, it's either you'll find these kind of questions on the assignments. I won't be there, ne? I'm still going to do the question with you. I just want you guys to attempt the question so that I'll see, I'll see if you guys, you do understand what we've been doing on the last 3 sessions we had together. I'm still going to do the question with you.
No, ma'am. I'm failing to find answers. I don't know where to go.
After clicking on polls, what do you see, brother? There at the top, next to view. Click on polls there.
Let me see.
Don't you see the question, the answers and the actual picture?
I saw the questions, but I can't see what we call answers.
The answers are on top of the picture. Once you exit the picture, you will see the A, B, C, or none of the above.
Oh, okay. Let me go and check.
Okay. Mr. Ngomo, just to ask a question, I heard you mentioning that you've extended the assessment date. Did I hear you correctly?
Yes, you did all the assignments.
Oh, okay, all right. right. Okay. I'll go and check then.
I even sent an announcement, even posted under the discussion. Do you even guys make use of the E2 test?
Yes, but I haven't checked today. That's the thing. I just came out of work now. But I'll
Alright.
check. Thank you.
Good evening, Ms. Nkomo.
Yes, hi.
Hi, ma'am. I had load shedding last week, so I could only attend that first class on differentiation. Where can I find the other class videos? I don't get it on my Unisa.
I've posted the classes, the 2 sessions we had, and under the lessons, we were still doing lesson 4. So that means the links to the recordings are under lesson 4.
Okay, thank you, ma'am. I'll have a look.
Where you
Thank you.
find the first link, yeah, they're all there. Are you guys done?
Yes.
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 So, ma'am, I have a question. I don't know if I should wait for everybody to be done or I can ask in regards to this.
If it's based on this question, you can wait for
Wait.
everyone.
Okay.
Okay, those of you who are done while we're still waiting for others to finish, please try and attempt number 2. Guys, you have 1 minute to finish up. You can't be doing one question for like 30 minutes. Okay, for question A, we have 20% for A, then for B, 38%, C, 18, D, none of the above, 24%. We still have a long way to go. You guys, we have to study. Have you guys attempted assignment 2 already? If you still have attempts on assignment 2, please do not attempt it. Please leave at least one attempt or 2 until maybe next week. I don't know. What is the new date for assignment 2? It's in April. They are all in April.
It's the 12th of April.
12th of April. Okay. Maybe you guys, you can start attempting it after the 29th. But this is the last session, tutorial session I will have with you under these chapters that we had. And we are left with the higher order derivative. And yeah, the application. Then after that, we'll have another tutorial after doing the application. Then you guys, you can use your last attempt if you still have one. But for now, please make sure you are left with 1 or 2. Do not use all of them. Okay, I'm still going to do the question. You guys, you should work on number 2 now. We have 5 questions and we have 1 hour, 30 minutes. In the exam, you'll have 25 questions. You'll be given 2 hour, 30 minutes.
Ma'am?
So you can't tell me you'll do 1 question and for 30 minutes. Yes?
I'm unable to open the second question.
It's also there on the pool. It's there too. And I'm even sharing the screen.
The screen is
All
more.
of you can.
We can see the screen, we can see the picture of the questions, but it's just not clear.
Okay, just check under the polls, like you guys did for question 1. The thing is, Teams doesn't have what is maths commands. For other questions, I will have to type. I won't have to post a picture. I will have to type if they don't need maths commands. But this one, I needed to use to write the equations, and they don't have that tool here on Teams. And Moodle, it has a limited number. It takes a limited number of people, so I can't go and teach them. And it wouldn't be fair if I was to say, you guys, we should go to Zoom. I can't give you a short notice like that. So we just manage this. Check under the polls, there's question 2, then yeah. Okay, but can you guys see the results for question 1, the correct answer?
Yes.
Yes, ma'am, we are able to see that.
All right.
About the results for question 1, I don't see how A is right.
I
still
think
about
that was
to
a
do the
question that
questions
I
with you.
wanted to ask.
Yeah, because
I wanted to
Sorry.
ask, ma'am, if let's say you had for question 1, let's say we had those options, however, A wasn't there, was C going to be the right question since it's like A is the simplification of C?
Nope. No.
It's still
actually.
going to be incorrect. Sorry?
Yes. Yes. You see, in C, there is no minus 24. I simplified the parts, but I left minus 24. And what else did I do?
Sorry, ma'am, I'm talking about
Yeah, but
question
it's
1.
wrong. Yeah, I'm talking about
I'm talking
question
about
2.
question 1. No, so I'm talking
Question
about question
1.
1. You've got in the second term 5/2, the cubed root of t, but should it not be 5/2, the square root of t cubed?
Okay, for B, there is no cube root.
No,
but
not for
then
B,
for
for A.
C, for A is correct. I'm still going to show you how did I get to that answer. But A is correct. The rest of the options B and C, D, yes.
I know you're still going to show us, but I just know that when you're working out, you're taking, so it was t to the 5/2, and you take the 5/2 down as the numerator, or not the numerator, sorry, you times it by the 5/2, and then it becomes t to the 3/2. But t to the 3/2 is the square root of t cubed, not the cube root of t.
What was your question again?
So for the term t to the power
the
of
second
5/2,
term,
yeah.
It's
So you take the 5/2
the one with
down.
5/2 root that. Okay.
So you take the 5/2 down, and then you minus 1 from the exponent, so that is then t to the 3/2. But isn't it t to the 3/2 is the square root of t cubed, not the cube root of t?
I think you're confusing yourself. You should just wait until I do the question, because before I differentiated. I first simplified this question.
That's fine, ma'am. I completely understand.
T squared minus half, and
Jamie,
I had t to the power 2 minus half. That gave me 3/2, right?
Yes.
And the second term, I had 3 minus half. That gave me 5/2.
Yes, I understand that, ma'am. I'm saying once you differentiate, I'm talking about, because t to the half is the square root of t, right? Therefore, t to the 3/2 is the square root of t cubed, not the cubed root of t.
No, I think, Jamie, you're confusing yourself, because remember,
that's why I said
3 over 2
should wait until
no, that's just
I write the
basic
question.
math.
Yes, 3/2 minus 1, it's half.
But it's not 3/2 minus a half. It's 5/2 minus 1, so that's 3/2.
No, I'm talking about the first one.
I'm talking about the
not
second term. That's the thing. I completely get the simplifying, the everything out, timesing out. I've got it all the way. It's just the basic math of
what do you get when you subtract 1 from 5/2?
3/2. That's my point.
Yes,
I
that's
don't
why
think you're understanding. Yeah, but the t to the 3/2 is not the cubed root of t. That's not, they don't equal the same thing.
Oh, I made a mistake when I was writing. That
Yes.
part should be there on top. It should be 5/2 times the cube root of t.
But
But
ma'am,
not
it's
the
still not
cubed
the
root, it's
cube
the
root. It's
squared
the square
root
root of t
cube.
to the 3.
Thank you.
Square root?
It's the square root of t to the power 3.
No, we have 5/2 minus 1.
5/2 minus 1 is 3/2. We all understand that. It cannot be the cubed root of t. It has to be the square root because the denominator of your exponent is 2. So it has to be a square root.
That is true. It should be 5/2 square root of t to the power 3.
Thank you. So answer A isn't right.
Yes. Actually, yeah.
Are you guys done with number 2?
Yes, we are.
Yes, we are.
Yes, we are.
Yes, no?
Yes, we are.
Okay, let's
We
just do
are.
number 1 together.
Yes.
I'll show the results for the other questions. We have E, ET. Can you see my screen, right?
Yes.
Yes, we can.
Oh, this is C squared. Minus
Sorry,
T
ma'am.
cubed over root C plus T cubed minus 3 2 to the power 4. Okay, this is what we have. I first simplify this part. If I simplify this part, I will have T squared over T to the power 1/2 minus T cubed over T to the power 1/2 plus T cubed minus 3 T to the power 4, right? Still, on the second step, I simplified again before I differentiated. So this means we'll have d over dt into t squared minus 1/2 minus t3 minus 1/2 plus t cubed minus 3 t to the power 4, right? Okay, then collected like terms here. We have 2 minus 1/2, right? That would give us 1.5, which is 3/2. So this means we have t to the power 3/2 minus, we have 3 minus half. That means we have 2.5, which is the same thing as 5/2, right? So this means we have t to the power 5/2 plus t cubed minus 3 t to the power 4. Okay, from here we can differentiate. Yes?
Your pen has stopped writing.
I think the screen is slow because as you are writing, it's not going with you. It takes time for it to appear on my side. I'm not sure if I'm the only one.
I think it's It's either my
Yes,
network or
yes.
I think you are too
I
fast
guess
on the
it's my
screen.
network then.
Yeah, same.
It's the network.
Okay, but it is coming up. Just that it's slow. It's very slow.
Okay, from here, I then differentiate it, right? Using power rule in all the terms. Okay, if we use power rule here, we'll have 3 over 2 t to the power 3 over 2 minus 1, right? Minus 5 over 2 t to the power 5 over 2 minus 1 plus 3 t 3 minus 1 minus minus 3 times 4 t 4 minus 1. Right, then we simplify. If we simplify this, we'll have 3 over 2 t to the power, okay? We have 1.5 minus a half minus 1, that's 1 over 2. Then minus 5 over 2 t to the power, we have 5 over 2 minus 1, that is 3 over 2. Because it's 2.5 minus 1, it's 1.5. Plus 3 t squared. Then we have 3 times 4, that will give us minus 12 t cubed. And if you want to, okay, because this one is not part of the solutions, the one we had, it had square roots, right? And if you simplify further in that form, you'll have 3 over 2 root t minus 5 over 2 cube roots of t plus 3 t squared minus 12 t cubed. You can leave your answer like this.
Ma'am?
Yes.
How did you get the cube root of t from t to the power of 3 over 2? Shouldn't it be the square root of t to the power of 3?
It's 3 to the power 2 to the power t cubed. Yo, sorry about that.
So, ma'am, do you agree that C is correct?
No.
Like, because it's the simplification of your answer.
I want to check I want to check number C first, because if I have this string, I can't see that option.
There was no answer.
As number C. Okay. It's 3 over 2 root 2 minus, yeah, this part is supposed to be, yeah, there is no answer. Okay, I'm going to edit this question. Okay, I will edit after.
So which is the correct answer for question 1?
None of the options are right.
Yeah, none of the options are right.
Sorry?
None of the options are
Options.
right.
Oh, okay. Thank you.
Yeah, it's supposed to be D then. Like I was setting these questions while attending a meeting. Just their errors. Yeah. Are you guys done with number 2? Yes, no.
So busy, man.
Again, for A, we have 21, B, 42, C, 18, then D, we have 19%. Okay, at least here we have the highest number on the correct solution. Okay, you can work on.
Sorry, ma'am, am I the only one who's lost on how to vote? Which answer that you're choosing? Or do you just write in the chat box?
You just select the correct answer under the chat, under the question.
Okay.
You guys, you can move to question 3.
Hi, ma'am. Hello, ma'am. Miss Nkoma. Hello.
I'm here.
I was checking question 2 and 3. They look the same. I don't know whether it's from my side.
They do?
I think they look the same. They are the same.
Question 2 and 3. So, okay, this is question 1. This is question 2. This is question 3. Nope, they don't look the same. They're different. When you're done with number 3, number 5. Okay, let me wait on number 4. We only have 30
some of
minutes.
us are not done with question 3.
You did not even take the question. but it's still there under the pools.
Oh, okay.
Are you guys done with number 3? Yes, no? Hmm? Okay, this is what happened here. On number 3, I just wanted to select D, but I chose the wrong one. C. I wanted to select none of the given solution because there is no answer there. So it's D, not C, number 3. And then for the percent, most of you chose the wrong answers, the wrong solutions, possible solutions, the wrong answers, because the correct answer, it's the last one. There is no solution. And only 19% of you chose the correct answer. Many of you here, 128.
How, ma'am, is it possible for you to share your answer?
Those of you who are done with number 4, you can work on number 5. My network is bad. Mhm. Okay, that's fine.
Sorry, ma'am, I just want to ask.
Selected for
Are you still
question 5.
going to do question 2?
I'm still going to do the questions that I haven't done.
Oh.
Person Koma? Person Koma? Can anyone hear? Ozzy? Hello?
I can hear you, but you're
can hear
talking
you.
like very low.
I accidentally chose on question 5A, and that was my answer for number 4. Can you please resend me the question 5?
Can I please do what?
I answered the wrong question. I was supposed to answer question 4, and I answered question 5. Do you understand?
Yes, but question 4, it's still there. You can still go and answer it.
Yeah, but now my question
I
5
can't
is
edit
wrong.
questions now. You remember there was a wrong question. I couldn't edit it because we are already live. So I can't edit that questions too. I can't take away your answer.
Sorry, Nolwazi, to disturb you.
Yes.
Can someone please assist me here? I don't know where to get the polls, where to vote. Because for me to get the questions that you're sending out, I go to the chats. And then I don't see question 5 as well. I can only see question 1, 2, 3, 4, but I cannot vote. I can only see the questions that are written in pen.
Okay. The solutions are above the picture.
Violeta,
Hi.
when you click on polls, the top, what happens on your side?
I don't see polls. I'm
Are
using
you
a phone.
using a cell phone?
Yes.
Oh, okay. I think that's going to be an issue. I don't know. If someone else is using a cell phone, can they just answer Violeta? Because I think most of us are using laptops or computers.
Oh, that is
If there's
right.
someone who has a cell phone, they can just suggest where to go.
If you can,
Using
Will,
on
if you can
click
check
on
the
the 3 dots at the bottom. When you click there, there's apps. When you click on apps, you scroll down to polls with the one in the brackets. Do you see it?
Still loading. Oh, now I see them. Thank you very much.
All right.
Thank you.
Okay, for number 4. We have D again. You guys, you have 2 minutes to work on number 5. So let's go do all the questions. We don't have enough time. Oh. Okay, I selected the wrong one again. Number 4, it's none of them, none of the above. I didn't notice that the answers were shuffling. I thought I still have that, I still have C at the end, but they shuffled. So that's why I selected the wrong one again. But the answer is none of the above. None of the given options is correct. I guess that what happened with number 3 when I was selecting, they shuffled again.
Hi, ma'am. I think you are right. They do shuffle because on my side I can see 11 quizzes. So I don't know whether I'm on number 5 or what.
Yo. I guess next time
Now
I
that
have to the back.
No, maybe if maybe you I don't know if it's possible if you can just read the question that we are doing, because once you submit they shuffle.
Yeah, true. Okay, I selected the last one again. They did shuffle none of the given answer, and then again they did shuffle. So it's not B, it's the last one. D.
But ma'am, how do we know that we are doing the same question?
You just have to do the question, you select the answer, you check another question, you work on it, you go and select the answer.
Yeah, I'm saying if it's question 5,
The thing
how
is,
will
I
I know?
have to open. How would you know that's question 5?
Yeah, how will I know it's question 5? The question 5 that I'm doing, how will I know that is the same question 5 that we are doing? Because once you submit the answer, this question shuffle.
Only the the possible solutions under the question shuffled, not that the question shuffles too.
Or only the answers?
Yes, you see here on the screen, question 5, there is A, B, C, D. Then there is
okay.
none
From
of
my
this.
side,
Then
from my
after
side, question 5 is
they
differentiate
move
following
like
function. Is it the same as on your side? F of x
yes,
equals to 15 divided by x is the same.
yes.
All right.
Only the answers shuffled, like A move, okay, like here, A will move to the end, B would be the third, C would be the first one. They shuffle like that, not that the questions.
Okay.
We only have 5 minutes remaining. So I suggest we all work on this together. Let's start with questions.
Yeah, I agree with you, ma'am.
Are you done? So,
I think we can use the remaining 5 minutes to work on it together.
We are done. Some of them we are stuck, so we might as well start.
Yeah, might as well just do it, all of us.
Jeez. Why around 8? What is happening around 8? The questions. Yes, we have question 2. Net differentiating y equals to t cubed plus 8 times 2t to the power 4 minus 3t minus the cubed a with t, right? And we are asked
I
to
don't know if it's just
differentiate.
me, but I can't see your screen.
You're not sharing your screen here.
Yeah, I
Me
can't
too.
see.
Can you see my screen now?
It's
Yes,
loading.
no?
Yes, we can.
Yes, we can.
Yes,
Yes.
thank you.
Right. Thank you. We are asked to differentiate this question on number 2, meaning we are asked to find y prime. Okay, just going to
So
separate
which question
this.
are we doing now?
We are doing number 2. T of t cubed plus 8 times 2t to the power 4 minus 3t, then minus d over dt of t cubed e to the power 3t, right? Okay. First, you need to know which rule are you going to use here. Okay, we have a product of 2 functions here and here, meaning we have to use a product rule. Also here, we have a product of 2 functions, this one and this one, right? Remember, the product rule, you differentiate one, you keep one, you add, you differentiate the other one, you keep the other one. Okay. For the sake of space, this is what I'm going to do. Okay. I'll first differentiate this 1, meaning I'll have t cubed plus 8, this sign, it means I'm differentiating, times 2t to the power 4 minus 3t, right? Plus, I'm keeping this one, differentiating this one, t cubed plus 8 times 2t to the power 4 minus 3t. I'm differentiating, I'm going to differentiate. Then here I have minus of, okay, I'll first differentiate this. I'll first differentiate 3 to the power, ne? Times 3t. I'll add and differentiate e to the power 3t. Okay, do not forget this minus. Break. Do not forget this minus. Okay, we can start differentiating now. I will start with this one. If we differentiate this, we use a power rule, you'll have 3t squared times 2t to the power 4 minus 3t, right? Then here, if you differentiate this, you'll have 8t minus 3, right? Then minus, you have this bracket. If you differentiate this, you'll have 3t squared e 3t, right? And if you differentiate this, you will have plus 3t cubed e 3t. You know we are using a chain rule here, right? So I'm just giving you the answer because you guys, you've already attempted it. But I used the chain rule here to differentiate this. Okay. Then was it simplified? Yes. Okay. Then the next step is to simplify. Okay. If you solve this bracket, you'll have this times this and this times this, and that will give us 6t to the power 6 minus 9t to the power 3, right? Then you have plus this bracket. This bracket will give us 8t to the power 4, right? Plus 64t. Okay, I said this and this, and then this and this. Okay, minus 3t cubed minus 24, right? Then I have this times this negative, and that will give us minus 3t squared. Okay, let me do this. Let me take out the common factor here. If I take out the common factor here, we'll have minus 3t squared.
Hello, ma'am.
Times, yes.
As much as I'm lost, it's okay. But I wanted to ask, 6t to exponent 6, how did we get to exponent 6?
We have this times this. T squared
okay.
times t to the power 4. It's t to the power 6.
Sorry, Nolazi, can you scroll up a bit? I've missed you somewhere here. On the second last step where you have 3t to the power 2, ne? After that plus sign, you have t to the power 3 plus 8, and then you've opened the second bracket. But you're not supposed to have 8t to the power 3 minus 3 there, because we're differentiating was 2t to the power 4. What happened to that power of 3?
You mean in this bracket? Here.
No, okay, on the next line.
Next line. Yeah. If you differentiate, this bracket, what do you get? You get 3t squared, right? Because, okay, if you differentiate 3t cubed, you will obtain 3t squared. If you differentiate E8, you will obtain 0. So there is no need to add 0. That's why I only have this.
But then when you go further, when you're differentiating G, let's say that is F, ne? That you've just differentiated now.
I keep this.
G is 2t to the power of 4 minus 3t. Are we not supposed to have 8t to the power of 3 minus
yes, to the power 3? Yes, it's to the power 3. Thank you. That means, okay, because we kept this, then we differentiate this. This would give us 80 cubed minus 3. I want to take this down. Okay, that means, okay, this part is fine. And here, this and this, it's this. No, now it's 6. Then this and this. Oh, it's this and this. 64 t cubed. Then had this and this. This one is correct. This one is minus 24. Okay. Then I have, okay, now I'm collecting the like terms again. Let me just put this E here. E, let's see. Okay, we have 6 and 8. That will give us 14, right? 14t to the power 6. And we have 3. How many 3s? We have this one. We have this one. Do we have an extra? Oh, yeah. So this means we have 64 minus 3. That would give us 61. Then minus 9. That's 61 minus 9. That is 52. It's plus.
Miss Nkomo?
Yes.
Before you continue, why is the e to the power of 3t outside the bracket? Can you please explain that?
I was taking out a common factor here.
Can you explain it from where you
two?
From where you took out 3 to the power of 2?
Yes, I was taking out a common factor here, which is 3t squared e to the power 3, right? Okay.
Yes.
But when I was writing 3t squared, I forgot to write e to the power 3 here. I wrote the remaining parts. Then that's why I had to write it here. It being here or here, it doesn't.
Okay, thank you.
That's the answer. Okay. To the power 3. Then we have, okay, minus 3t squared e to the power 3t. times 1 plus t minus 24. Okay, that is our B.
Miss Nkoma,
Anytime. Yes.
would it have been wrong if from the beginning we would have just multiplied the brackets within each other?
You would have gotten the same answer.
Okay, so even if you do it in that manner, it's correct.
Yes.
Okay.
Ma'am, did you notice from the answers on question 2, it says 55. That's why we chose D.
I was about to say
That's
that.
why I said there is no solution.
Oh, okay.
Apparently, I got this answer.
Which
52.
one? It's not part of the solutions there.
Can I ask Ms. Ngoma, when you were differentiating e to the power 3t, what did you get?
3 ET.
Yeah, e to the power 3t.
3
ET.
Did you ever get the same answer? The final answer. Okay, let's move to number 3. Find the derivative of this function y equals 1 over 14 e 40 plus lim t squared of square root of t squared plus 15, right? Okay, y prime would be 1 over 14 e 14t derivative plus the derivative of lim t squared over square root of t squared plus 15, right? This time we are differentiating. Okay. If we differentiate this, you should get E 14t, right? Then we differentiate the second part. Okay. Here, I let U to be this function, this whole function, right? But remember, in chain rule, you still need to find the derivative of U, okay? We have this part over this part. Okay, I let all this term to be U. It's okay. U equals to t squared over square root of t squared plus 15, right? You can write this like t squared times t squared plus 15 minus a half, and then you use a product rule to solve this. Or again, you can use the quotient rule, and then you differentiate this, you keep this, you subtract, you differentiate this, you keep this, and everything to the power of these parts, the denominator to the power squared. It depends on you which ones do want to use. In this case, you'll get the same answer. Someone who used the quotient rule and the one who used the product rule, you will get the similar answer. Okay. Let's say we use the product rule here. Okay, we'll have du over dt equals to, differentiate this, we'll have 2t, I keep this, you'll have t squared plus 15 minus a half. Then I differentiate this, I keep this. That means I'll have minus 1 over 2 t squared times t squared plus 15 minus 3 over 2 times 2t. Okay, then if I simplify this, that means I will have 2t over the square root of t squared plus 15, right? Minus t squared over 2 over the square root of t squared plus 15 cubed. Okay, this is just du. This is our du, right? Remember, u is from here. We said we let this function to be u, right? So this means okay, I'm gonna write it like this. Ln of t squared, okay, t squared over square root of t squared plus 15. Okay, the derivative of this, right? It should be the derivative of ln u, the derivative of ln u times the derivative of u. Okay, if you differentiate ln u, you will have 1 over u, right? And we said the derivative of u is 2t over square root of t squared plus 15 minus t squared over 2 times the square root of t squared plus 15 cubed, right? Okay, then you put back the value of u. That means you'll have that means, okay, we have 1 over u, right? This means we'll have the square root of t squared plus 15 over t squared, right? Times 2t over t squared plus 15 minus t squared over 2 times the square root of t squared plus 15 cubed, right? Then you add, do not forget to add this e to the power. So plus e to the power 14t. And this is our final answer. Okay, you can still simplify these parts. It's still fine. And also, okay, let's say you were to take out, okay, from here, you take out t. If you take out t here, t and t will cancel out. You'll be left with 2 over this. And then here you'll be left with 1 because we have t squared over t squared, right? That is 1. But still here you'll have just 1t, because remember here this t, we have 1t over t squared. I'm not sure whether I'm confusing you guys now or what. Okay, let me just do this. I have t squared plus 15 over t. I'll say this times this, right? So this means we have 2t over t squared plus 15. Again, this part times this part. So this means we have minus t squared times t2 plus 15 over t squared times square root of t squared plus 15, right? Okay, this
You
and
forgot
this will
to,
cancel out. I forgot to, thank you. This and this will cancel out, and 1t here will cancel out with 1t here. So this means you'll have 2 over t here on this term, right? Okay, let me add this part. Plus e to the power 14t, right? Then we have t squared over t squared. That's one will cancel out. And then we have half, okay, minus 1 over 2. Okay, remember, this is 3. Okay, we had, did I leave 3? Okay, I left cubed here, there on top. Okay, then times, we have half. Remember, this is 3 over 2, right? It's t squared plus 15 to the power 3 over 2 if I move the square root, right? So this means we'll have t squared plus 15 to the power 1 over 2 minus 3 over 2, right? So this means our final answer is 2 over t plus e to the power 14t minus 1 over, because this would give us 1, right? Will give us minus 1. 1 over 2 times t squared plus 15. Yes. So this is our final answer. Did I leave any term on top? Okay. It should be your final answer if you were to simplify further, because we can't simplify from here unless you want to say 2 times this times this. Besides that, there is no simplification. Yeah, I think there was an answer. Did we have this as the solution, possible solution? Let me see. This is question 3. Question 3.
No, there was no answer. There was no correct answer.
We didn't have this. We had that. We had this.
No.
Let me see.
It doesn't have the 2, man. See?
Oh, okay. Yeah, I see. It didn't have the 2, so that's why there was no possible solution. Okay. Thank you. Right. Do we have questions?
Yes, ma'am. You used the product or the quotient rule when doing this, because I just got lost. I don't know where.
I used the product rule. Remember, I changed this fun. I wrote this function in this form. But still, if you're using the quotient, okay, I'll differentiate these parts only, right? We have u equals t squared over t squared plus 15 to the power a half, right? Okay, du over dt will give us, if we differentiate this, we keep this, we'll have t squared, right? Times t squared plus 15, right? You subtract, you keep this, you differentiate this. If you differentiate this, you'll have 1 over 2 t squared times t squared plus 15 minus 1 over 2 times 2t, right? Because, okay, then everything to the power squared. Okay, so that means we have t squared plus 15 squared, right? Okay, let's try and simplify this better. Remember, square root, it's the same thing as that, so function to the power a half, right? So this means our du would be, okay, first let me start with this part.
Ma'am, 1 after minus 1 over 2t squared, you differentiated the denominator.
Yes, I differentiated the denominator. Oh, okay, here it's minus half t squared. Yes, it would be minus half t squared because of this t squared times this function to the power minus half times 2t. Yes, this half and this term and this term. Okay, just 1, 2, 3. You will get when you differentiate this function, right?
You lost me there, ma'am. I don't understand how you differentiated.
T squared plus 15 to the power a half, right? Let's u to be t squared plus 15, right? Then that means u prime would be 2t, right? But that means here we'll have u to the power a half, right? If we differentiate u to the power half, you'll have 1 over 2 u minus 1 over 2, because you'll have half minus 1. That means you'll have this, right? Okay, remember the derivative of this part, it would be, okay, it's, let me write it like this, t squared plus 15. The derivative of this part, it would be the derivative of u to the power a half times the derivative of u, right? Okay. The derivative of u to the power a half is 1 over 2 roots minus 1 over 2, right? But the derivative of u is 2t times 2t. So this means we have 1 over 2 roots u times 2t, right? But u is equal to t squared oh, we let u to be that. So that means we substitute u here. 1 over 2 times square root of t squared plus 15 times 2t. These 2 and 2 will cancel out, and you'll have t over square root of t squared plus 15. This is just the derivative of this, right? I haven't added this part.
Just a quick question: when you wanted a derivative of u in that page where you are, can you go up a bit?
Yeah.
Yeah, where you are. Did you use a quotient rule there?
Yes, I used the chain rule. Okay.
The chain rule.
To differentiate everything, to differentiate everything, I used the chain rule. But when I was differentiating, I used the quotient rule when I was differentiating these two terms. But when I was differentiating these parts, that's when I used the chain rule. Remember, for a quotient part, for a quotient, we need to differentiate this, we keep this. Then you subtract, we then differentiate this, you keep this. But when you differentiate this, you can't differentiate it straight. That's where the chain rule comes in. Okay. This the reason I don't know the reason. Okay.
Can you scroll up a bit, Novazi? Just.
Pardon?
Can you scroll up a bit?
Yes.
Can you scroll more? Oh no. Yeah. Oh, right there. Can it, where you have let you be? Can you scroll down a bit? There's I've missed something below that. Okay, thank you. I got it. Thank you.
Okay. Yeah, like I had something like this. T squared plus 15 to the power a half, right? The reason I just wrote the answer without doing the calculation is that for chain rule, I know that the answer to that will always be the derivative of the outer function times the derivative of the inner function. That's why I just wrote half t squared plus 15 minus 1 over 2 times 2t. You know why? Okay. First, I said to the power half. If here we only had just a variable, what would be the derivative of this, right? If we had u to the power half, the derivative of that would be 1 over 2 u to the power minus half. Because you have, if you had u to the power a half, you'll have 1 over 2 u to the power 1 minus half, right? I just assumed, like, I just asked myself what would happen here if this was just one variable. That's why I obtained this. But then this is not just one variable. It's a function. Then what is the derivative of this function? If you differentiate 15, you get 0. If you differentiate t squared, you get 2t. That's why we have we have this, right? Again, if you had something like this, t squared plus 10t, right, to the power 100, right? Just assume you have just one variable here. If you were to differentiate that function, what would be your answer? Like you are differentiating u to the power 100. You'll have 100 u to the power 99, right? But this it's not one variable. You were just making assumptions, right? But what is the derivative of this function exactly? It's 2t plus 10. The more you do more examples, you notice that you don't have to do all the steps. That u be that function, then you find the derivative of u. You can just like assume from your head that's okay, let me just picture this as one variable. What would be the derivative of this function? Then you'll get that it's this times that one variable to the power 99. But this, you were just trying to picture it as one variable. Take it back to the function that you are given, right? You are given t squared plus tt plus 10t. But what is the derivative of that function? It's this. Then multiply the whole thing with that function, with that derivative. Is it fine? Did I lose you?
No, you did not. You're still here.
Thank you. Okay. Now we have question 4. Question 4 was P equals 20 plus 20 ln Q squared plus 2Q plus 5 over Q plus 6Q, right? Okay. First, I will do the derivative of this and then come back and do the derivative of this, right? So this means we want to find the derivative of 20 plus 20 ln Q squared. We want to find the derivative of this function, right? Okay. Again, just assumed here you had one variable, like you had u squared. What would be your answer? Your answer would be 2u to the power 1, because you'll have 2u, 2 minus 1. 2 minus 1 is 1, so that's why we have 2u. Remember, here we're just assuming that what if this was just one variable? But since it's not just one variable, what is the derivative of that function, the one that you assumed it was u? You have to multiply with it here. So we have times, the derivative of 20 is 0. The derivative of 20 ln Q, you'll have 20 times the derivative of ln Q. We said if you are differentiating ln one variable, you'll have one of that variable, 1 over that variable. So this means we have 1 over Q, right? And if you simplify this, you'll have 2 times 20 plus 20 ln Q times 20 over Q, right? Then you can multiply this with this. If you multiply these two, you'll have 40 to 20 plus 20 ln Q, right? Over this Q. Okay. This is the derivative for this part, right? Then the other part was the other part was 2Q plus 5 over Q squared plus 6Q. Want to find the derivative of this. You can use quotient rule, meaning we have to differentiate this 2Q plus 5. We keep the lower part, which is Q squared plus 6Q. Then you subtract, you keep the upper part, which is 2Q plus 5. You differentiate the lower part, which is Q squared plus 6Q. Okay, this stands for derivative. Over, you have Q squared plus 6Q squared. Yes.
I think we had Q cubed instead of Q squared.
Oh, that was right here. Okay, doesn't right. Okay, it doesn't want to write, but let's assume it was squared. And it's, oh yeah, thank God. It cubed. We had cubed. Thank you. Then you differentiate this part, you keep this part. If you differentiate this, you'll have 2 times, you keep this part, Q squared plus 6 cubed, right? Then you differentiate this part, you keep this part. You'll have minus 3Q squared plus 6 times, you keep this part, which is 2Q plus 5, right? Over, we keep this part squared, cubed plus 6Q squared, right? Then you can simplify. Yes.
Supposed to have 2 times Q cubed plus 6. And then in the next bracket, you're supposed to have
I differentiated this, right? If you differentiate this, you'll have 3Q squared plus 6. Then I kept this, it's this part, right? Then I took this down as it is, right? Here I differentiated 2Q, I obtained 2. Differentiated 5, it was 0. So that's why I have 2 times this part. Did I answer you? Yes, no.
Yes, you did.
Thank you. Okay. After simplifying this part, don't forget that you still have the first parts that we differentiated. This part. This part. So you just have to add it to this part after simplifying it. Okay. Do we have questions?
Yes, I do have one. Can you scroll up a bit, please?
Yes.
Can you scroll up a bit so see the last part of the calculations?
This part?
Yeah, yeah. Look, okay, for us to get to the last answer, you differentiated that 2q plus 5, and then you got 2. That I get. And then in the next bracket, where you're not supposed to have q cubed plus 6q, because what I'm worried about now is that our answers would be a bit different because of the confusion of that q squared and that q cubed.
2 squared and 2 cubed.
No, what I'm saying is we've okay, and we've
Are you
differentiated
saying
the
you
first
want
part.
me to start with this bracket and end with this bracket?
No. On the first part, you have two on the second last answer, you have 2q plus 5, ne? That you have differentiated, ne? And then in the next bracket, you have q squared plus 6q. You were supposed to have q cubed plus 6q.
Oh yeah, there's a
But
3 here.
q plus q. Yeah. So now what I'm worried about is there where you have your 3 there. Because what I'm worried about, our answers would be, will have a slight change towards the final answer.
Okay, yeah, there's a 3 here.
Yeah, that is correct. Then every step, then after that I do understand. Thank you very much.
Ma'am, the first one you used chain rule to differentiate it.
Yes, I used the chain rule to differentiate the first parts. Because you have a function, then this, right? You have an inner function and the outer function. Did I say let you? Yes, I did. Yeah, I used the chain rule.
Okay.
Also, again here, this part, you would have write this part as q plus 5 times q plus 6q minus 1 and do a product form. Oh, but still, we're going to use the chain rule here. So it's better you do the chain rule straight here. I thought if I wanted to use the product rule, because if you use the product rule, you're still going to add the chain rule. So you use both. It's better you just use the chain rule straight. But sometimes you can avoid the chain rule like that by taking the other parts and multiply with it and add minus. And we end here if we don't have questions. My day started at 7 and I had back-to-back meeting in such a way that I had to set these questions while I was in a meeting. So I haven't rested today.
Miss Nkomo, can I
Yes,
see how you do that chain rule you're talking about for this specific example, the one you written in black?
you remember for product rule, you differentiate this, you keep this, then you add, you keep this, you differentiate this. When you differentiate this part, you'll have to use the chain rule because you have cubed plus 6 to the power minus 1, right? Okay. Yes. Let u to be plus 6q, right? So this means here, this function will be u to the power minus 1, right? So remember, the derivative of this part, squared plus 6q minus 1, okay, the derivative of it would be the derivative of u to the power minus 1 times the derivative of u, which is this one, right? Okay. Yes. If we differentiate u to the power minus 1, you will get minus u minus 2, right? Because you take this down, then you subtract 1. So you have 1 minus 1, this is minus 2, times the derivative of u. This is our u, right? And if you differentiate this, you'll have 3 cubed squared plus 6, right? Okay, yes. So this means we have minus 3 q squared plus 6 over u squared. But we know that our u is that's why I said you have to use the chain rule again. So you notice that we used the chain rule and the product rule, because this chain rule is only for this part, right? And we had 2 brackets. We differentiate this, you keep this, you add, you keep this, you differentiate this. And like I only did the parts where I was differentiating this, where we'll use the chain rule. So that's why I said, no, this is a long way, because we have to do the products and the chain rule. So it's better we just do the chain rule once.
Okay, thank you.
We still have questions?
Thank you, Nalwazi. This has really helped me a lot, the steps that you've done. So thank you so much.
Yeah, I'm glad I could help. Well, thank you guys for your time. I know I've taken another hour from you, but thank you so much for attending. We'll meet that other day, Monday.
Ma'am.
Thank you, ma'am. Thank you, ma'am. It was worth it.
Thank you.
Get some rest now.
I will
Thank
only
you,
sleep
ma'am.
a few hours. I still need to do the rest. Thank you. All right, you guys have a lovely
What are we
evening.
gonna